and he has also accorded CSI as Senior Research Fellow for 2 consecutive years, and he has around 28 publications and 6 book chapters and research papers is around 22. And I take this opportunity to make it comfortable to share the knowledge database with you, your students today in the Dr. Academy, welcoming you, sir, on behalf of the management, my registrar, and myself, to the guys, and I request you to take steal the show with the students. Sir, please unmute your mic.
Devan, thank you so much for your flattering introduction. I'm very, very happy to attend my findings with you all. So today, I'm going to say is a quick call. So today I will be speaking about the overview of my research, which I have done during the period of a decade or so using the scope model. So I think, can I share my screen now?
Yes, sir, please.
Yeah, I think it is visible to you all.
Yes, sir.
Okay. Well, good afternoon, everybody. So today I'll be speaking beyond the brain, which is from emotional stress to systemic dysfunction of stroke. So when I say beyond the brain, basically I will be talking about the stroke pathophysiology. So my this aim is focus on understanding the pathophysiology of the brain, and as well as the organal stress. For example, there are many organs in the cell like endoplasmic mitochondria, etc., which they in the pathophysiology of stroke. And not just confined to the brain, so we have also tried to understand the distal organ damage which is induced by stroke. So, in the coming 30 40 minutes, I will be speaking about the high risk of research, career understanding, and please feel free to stop me at any point of time if you have any. So, I think we all must aware that what is stroke. Stroke is a acute obstruction to the blood flow to the brain, so which will leave the patient with paralysis, right? So, and then so far we do have only one drug, which is known as recombinant tissue plasminogen, which is a thrombolytic. So with certain narrow therapeutic window. So the limitation is the patients have to rush to the hospital within 64 hours or beyond that, which it may be mild hard. So, but given the scenario, most of the patients in rural areas, we get in scenario or in many other places, or in the like of food prognosis, they might not reach the hospital on time. So therefore, many patients there is only a delayed care with trauma. So, and then beyond that point, we don't know what's happening exactly because over the time, every second and week, the brain damage processes and various types of metabolic pathways, either neuroprotective or neurodamaging pathways, they just play key roles in activated from time to time. And then after 24 hours recovery, you see, I mean, recovery is of like this, you see the major of the question is the navigation. So, apart from the RTPA, there are no other strategies for existing to limit the second brain damage volumes. And then many drugs aiming the mechanism that it is, they also have failed because of the complexity of stroke. So therefore, there is another thing. So on your left side, you see and therefore we have first, second, third generation recombinant tissue plasmids and islets. Now they have recognized and connected to the next phase. in the place. So these are the information branding available. And then for neurologists also there are different patient work. Like so, I will quickly take to the classification. So where the majority of this, 80% of those are ischemic in nature, and then about 10 to 15% are regularly, so the rest of them are surviving. And then my area is I would focus on civics because they are the 85% they constitute or 85% of the quota. So right, these are the research focus. So I do have management focus. So we will use focus leukemia and rats and mice. And then these are the various research focuses that I actually highlight. One is immune stress or unfolded protein response. This is also as the stress. Right? So within the cell, I mean, we all know that here stress is the major organ is responsible for lipid biosynthesis as well as protein synthesis, folding, etc. And then I'll also look at the post-translation modifications, like with modification, how the proteins are tagged, unfolded, misfolded proteins, which are accumulated after the stroke. So they are tagged by this small protein called vivificin, and they how this subject to the prison of vivification to restore the normal cellular level. So apart from that, we clinical studies are non-coding ones. We also do non-coding organs like clean writing microorganisms. So, and then the main thing is oxidative stress because brain is high in lipid content. So, and the oxidants, for example, we have some oxidant or antioxidants and release in liver tissue. So that makes the lipids in the brain more vulnerable to oxidation. So once oxidative stress is on, so it can remove many other pathways that can be regulated. So this is the animal model like we issue. So you must have heard about this animal model called middle cerebral orchid accumulation model in spiroid activity. So this particular model illustrates the human trauma model. So what we do in that system is we just isolate the common trait properties. So the midline identification, the identity of the PCA over here, and then external trait property and internal trait. So in the left side, what you see, the external trait property, what we do, we just make a small link, and then we introduce small nylon vesicles here. So this 3 nylon filament. So that will atmospheric structure via internal characteristic to block the middle cell because the 85% of the blood clots happen within this territory, MCA territory. So this is a very common model that integrates the view from body and also it consistent grade. So now I would like to introduce you to process. TP4 Ventura concept. So when we conclude an object, common characteristic. So what happens? That goes with this start. Let's say, for example, we stop the blood flow for 1 hour 16 days, and then after 16 days, we remove the filament, which are we re-establish the blood flow, which is called liver fusion. And then the liver fusion it could be detrimental to the cell, or at the same time, it is also predictive. And then during liver fusion, if you look at the brain, around skin region, skin core region. So where the neurons are irreversibly damaged and almost impossible to make them aware. So, in contrast, there is another region surrounding the grave of this Kimiko is known as Peninga. So, where there is still some left to collectional potteries, and then that is one of the that peninsular is opportunity, video opportunity, we can say that, and then we have a chance to say some neurons because there is still some ATP left. So if there is a whole region it lacks ATP because it is like we all know that the brain is even though it is comprises only 2% of the total body weight, but it consumes over 20% of the glucose. While so there is a minute disturbance in the blood supply, it should be detrimental to the. So these ischemic neurons are almost impossible to recover. So, but we focus on this cerebral peak. And then in this model, the brain areas are affected majorly of the cortex, central cortex, and this side. And then would you like to take a look about the central blood flow levels in this? The four regions you see. Where there is severe deficiency, so the central blood flow is not less than 15 ml mg per mg per 100 mg range. So then, whereas in film, right, you see, the normal blood pressure is anyway, so it's more than 55, 60. This is called OBPM. And then in the clinical patient, some moderate brain, central blood pressure. Right. So then, the outer Olympic zone you see here, with the reduced blood flow or respiration of 35 to 45%. So disturbances in it can lead to disturbances in neurotransmitters, balance, and then protein synthesis or preserved particulate. So these are some MRI images to find how the necrosis works. The necrosis means like ischemic core neurons damage in the necrosis. So they are irreversibly damaged and everywhere. And then surrounding zone is penumbra, and there is red zone, yellow, and then green zone. So you can see the table, the different that those levels and both of these green. And then coming to my side, so what we do, I'll get to that and I'll like to say, my side and I'll like to how brain damage is. For example, if you look at this picture, is it visible? So am I audible?
Yes, sir, please continue.
Yeah, right. So if you look at this slide, so I have shown two brain. These are actually two different brain. One I use as a brain, and so and zero for middle central organization. So where you see the two distinct regions, right? So one region is appears a red in color and on the left side, and one portion you see here is pale or it doesn't do anything. Why? So this is the dead. So this is after induction of experimental scope in our experimental area. Right? So this state is basically depending on the mitochondrial transfer chain. So we use the state called 235 prime vector, right? So where it reacts with mitochondrial respiratory chain and called saccharine hydroxylase. So with that, it reacts and it forms a red hormone. So whenever you see that this red hormone, it indicates that there is a live mitochondria, so therefore the issue is viral. So, and where located before, there is a line that so you can see any live mitochondria, this product is phase or state. So this is how we assess the brain damage. Right, and coming back to my statement. So, what